All right, I think we are all good to go. Um, I'm using the Zoom.us from from Canvas, and I'm also I have an account Zoom.us Pro that I can use to communicate one-on-one with you. If you have any question during the week, and if it's a time convenient for both of us, we can communicate. So at the same time, right now I'm taping also using my QuickTime application, and I will see which taping is the best one. And once this interaction is over, I will upload the file up to Canvas, and then you can review if you want it, or your classmates can also access that. So um, my understanding is I'm taping from Zoom.us and I'm taping from QuickTime. All right, so I have Raza, Sarah Castillo, Raymond, and what I would do, I will share my screen with you. You should be able to see my computer now, my computer screen. There you go. And let me go to, since this is the first meeting, before I start, I would like to ask you if you have any specific question regarding the course that is not clear or was not um, stated in the orientation. Is all good? And of course, I would like to know if you guys can hear me. Can you hear me? Can you all hear me? Let me put a chat here. Uh, okay, so you can hear me. You can hear me. Okay. Okay, so let me go back. Sharing screen. And since there are no questions, so I'm opening the course. So when you open the course, all your to-do list is right here on the right hand side. So for instance, for me, I'm supposed to go over and do like checking on some of the students and see if they have already submit their understanding of, for instance, replying to these students, say, okay, your orientation is done. And I have several other things, several other students that I have to just mark them as done with the orientation, right? But in your case, you have a discussion open. This is already open, and I have some students already posting information. So tomorrow I will have my to-do list. I have to come over here and read and post my own comments and of course grade. And you have future assessments coming up here, like if you haven't complete orientation, you must do by tomorrow, Wednesday. And this is important. By Wednesday at noon, I will shake the tree and make sure all the students that are not there yet, they fall down. So I will start dropping students tomorrow by noon, the students who either didn't complete orientation or have not started working the course yet. And the reason is, as I mentioned in your face-to-face orientation today, there's lots of information, and the best way for us to succeed in this task is to have you guys doing a little bit of activity every day, like 1 hour, that's more than enough. Post a comment and I will reply to you. That's more than enough. And that will keep you and give you some breathing power so that you can kind of have a nice picture of exactly astronomy is. You do have something flashing here. What is that? I don't know what that means. We also have homework number 1 open, and there is an extra credit going on that is also open. So those are things that you should be alert and be aware of it. So homework number 1 is due on January 4, which is 2 days from now, and the extra credit is going to be done on Friday, January 5th. Okay, so extra credits will be done on Friday, and as I mentioned in the orientation today, there are 3 extra credits with the reading material already open, but I will add more as the course evolves. So what's the point of these 2 days, January 2nd, which was today and tomorrow? Pretty much reading chapter number 1, and chapter number 1 can be read through Canvas. It's taking a while to open. There you go. And basically what chapter 1 does is to give you an overview of astronomy. Everything we are going to be covering in the next few weeks, 3 or 4 weeks, everything is kind of summarized in chapter 1. So in chapter 1, introduce who are the main components in our solar system: the sun, the planets, satellites, comets maybe, and asteroids maybe, without going to a lot of detail. And then there is a next hierarchy of objects. They are stars. And then there is a larger hierarchy of objects that include stars, and we name them galaxies. So galaxies are complex objects consisting of hundreds of billions of stars. But galaxies in the universe don't come alone. They come in groups, and these groups have a name, and the name is clusters of galaxies. Now, clusters of galaxies can be rich clusters or poor clusters. So rich clusters, very large amount of galaxies, thousands of them. Just give an idea how vast this universe is. And poor clusters of galaxies consist of few dozens. Like our Milky Way galaxy is a member of a poor cluster of galaxies. There are few dozen members, between 40 and 50 members. And that's how the universe is organized in large scale. Is a string of superclusters of galaxies surrounding voids, and these voids pretty much consist of space. And what we observe of this universe is that these voids, the space itself in between these superclusters of galaxies, tend to be expanding, and that's what we observe. We observe the universe expanding and growing size as we speak. So pretty much this is chapter 1, and you can read it in Canvas, and then you can move on to a next section, and then you go to the following section. Or some of you prefer to download the entire thing, the entire book, to your computer and read it independently. You can also do that. I think I have done here. Did I do that? I don't think I did. Let me see. Yeah, so you can go to the book webpage. And then you can find your book. So our subject is astronomy, and then you can download the entire thing. Bring whole low resolution, so don't take too long. And then, as you can see, you have the entire book available right there. Now, how do I recommend that you read the book, assuming that every day at 7 p.m. I will give a summary of the chapter itself, and I will try to highlight main points. Oops, no, the other way. There you go. This is your book. And then you'll find this all the chapters in there. You can click, if you download the entire PDF version, you can click on each chapter and it will take you there. And also to the sections in these chapters. Okay. But I would like to recommend, since there is not a lot of time, what I recommend is that you go to the last section and then take a look at the conclusion. What are the main topics in this particular chapter? Let me expand a little bit here. And there are recommended websites and places to go. For instance, in the videos, they are recommended towards the end. This video, which I go there, and let me bring the sound. It gives you some flavor of how vast and empty the universe is and some of its major content. Start from Earth. And then if we scale this dimension to 10 times as it is, where are we going to get? Think about our planet Earth, 13,000 kilometers more or less of diameter, like a soccer ball, 13,000 kilometers in diameter. And the pathways of the major artificial satellites orbiting Earth, but if we scale that to 10 times as Earth, we're gonna go to the moon. So the light takes 1 second to reach moon, and light takes 8 minutes from Earth to reach the sun. But in 1 hour, light has traveled to most of the major planets in our solar system. And then if we are at a distance equal or equivalent to 1 light year, that's how the sun looks like. It's not the brightest object in the sky anymore. Now, if you go to 50 light years, we are still within the galaxy, and that is a picture of the galaxy, what our galaxy, our Milky Way, would look like if seen from outside, and the nearby galaxies. And now we are really going away in our large scale universe. And these empty areas going like in a cone up and down is because it hasn't been mapped yet because of the galaxy's disk, preventing us from seeing that region. But our universe, as we learned in chapter 1, is about 13.7 billion years. So the universe started at a 13.7 billion years ago, and we know the different characteristics of objects out there in the universe because we can collect light using powerful telescopes, and we can also interpret the light that comes from these faraway objects. So nowadays we don't study astronomy, we study astrophysics, which is the use of physics and the knowledge of physics applied to understand and to interpret the physics processes that happen in stars and galaxies and in the universe far away. So our sun is just a normal star among billions of others. And what we learn, reduce a little bit the sound, and what we learn in the last 10 years or so is that our planet Earth is not some unique planet in the universe, as there are several other planets in our galaxies resembling Earth. In fact, it was found that planets or stars out there, they all have their own system of planets, and we are going to study that still this week, and they are called exoplanets. And now we are back to planet Earth and to the main point of chapter 1, which is to give us a sense how vast and empty the universe is. I mean, I don't know where you are exactly right now. I'm in my room, so I have walls around me, and when I look outside, I see some pathways and some trees and some distant mountains. In fact, I can't see now because it's night. But the main point is we have the impression that we are surrounded by things, and then as we learn in astronomy, in modern astronomy, the universe in its majority consists of things that we don't know what they are, and they are called dark energy and dark matter, and we are going to learn about these objects and these materials towards the end of our course. So if this is how I recommend you to read the book. Instead of, I mean, you can, if you have the time, read section by section, but I also recommend that you go to the end and try to get an overview of what is coming ahead. So, any question regarding, would you like to ask any question regarding all these discussions on chapter 1? There is not a lot of specifics. It's just a tour through the main components of our universe. Okay. In the quiz and the homework, let me go over the homework. There you go. Go to modules. The first homework, they are supposed to be closed on January 4. And the questions are more or less like this. I would say that the homework in chapter 1 is the one that gives some mathematics. You have to play with some mathematics here. Approximately, how many meters are there in 12 feet? So you have to come up with an answer, right? So what should it be? So 3 feet is about 1 meter. So you would go perhaps 4, right? Or not. I don't know. You do it. But then you go to the next one. And then how many nanometers are there in a millimeter? So all of that, it doesn't. It seems that you're going to be using a lot of math, but you're not. You just endure homework chapter 1, and well, because it's astronomy, we deal with the big numbers, and scientific notation is an important component of chapter 1. One of the central assumptions in astronomy is that the physical laws of nature are what? So what are the physical law of nature? And more particularly, what is the scientific enterprise? When we do science, exactly what we are doing? What's the difference between laws, principle in physics, and what is a theory? What's a hypothesis? So all these different aspects of the scientific method are supposed to be learned in chapter 1, a little bit in chapter 2, and here and there I try to revise these concepts as we go. But basically, nature has the last word in everything we do in science. Um, you observe something that repeats itself, that has some regularity. In fact, we as a species have been done that for thousands of years. We know the sun rises in a certain part of the sky, and a few hours later, the sun started going down in the opposite part of the sky, and then 1 hour or two later, the sun cannot be visible, is not visible anymore, and the sky becomes dark. There is no sun anymore. But just wait a few hours later, and the sun comes up again in the same sky region, not exactly the same spot, but in the same sky region, and that is the eastern sky. So you observe some regularity, and then you come up with ideas, with hypotheses to explain why this happened. So in science in general, we always do that. It is the repetition of this process. You observe something, and then you try to formulate ideas that can explain why the behavior, nature is behaving the way it does. So then you create your hypothesis, and then you test your hypothesis. And this is one of the major accomplishments of the scientific revolution that was brought to us by Galileo Galilei in the 1600s. Before that time, you could make any hypothesis to explain anything. Any idea is a good idea. So what Galileo brought to the discussion was, well, you can make any hypothesis, but you also have to test your hypothesis. You have to test your idea using perhaps a model, a representation of what the reality is, a scaling model of what the universe is, if we are talking about astronomy, in your laboratory, or you want to verify why things happen the way you do, and then you create some control groups so that you can test your hypothesis, if your hypothesis is verifiable or not. Now, if your hypothesis withstand tests, then I think you are in a good track to publish your idea. And then other groups in other institutes will try to reproduce your experiments, and you try to verify your hypothesis, and might find some flaws or not. One of the main points of science, and this is very much not understood by people in general, is that a scientist is not trying to prove that some hypothesis is truth. We don't do that. What we do, we try to negate the hypothesis. We try to find points in the argument, in the idea, in the theory that is not strong, that is not robust. We try to break down the castle of knowledge that we created with our hypothesis. Because if we can destroy the castle, it means that the hypothesis is not good, and then it's pretty much put it aside. Now, if your hypothesis withstand tests, and if different groups can also formulate different tests, and your hypothesis still understands all these tests, then we can move on to call your idea, your hypothesis, your explanation on how nature behaves. We can call this a theory. And there are several theories in science nowadays. One, we live in the Bay Area. We are subject to earthquakes. So the theory named plate tectonics is a robust theory that explains earthquakes, volcanoes, the major landscape we have on Earth, the fact that Earth has mantle with convective motions that generates all kind of activity, geological activity on Earth. And so all of these evidence, all these different facts have been consistently and elegantly placed in a theory that we call plate tectonics. The theory is basically, well, Earth is a planet that is divided, its crust is divided in 12 or more major plates, and these plates have motion. So sometimes the plates move apart, sometimes they move towards one another, and sometimes they pass one another. And by this simple theory, we can explain all kinds of things here on Earth: earthquakes, volcanoes, the shape of our mountains, San Andreas Fault, all kinds of things. And can explain how certain parts of our floor moves few centimeters a year. And that can be measured nowadays with the GPS. More than that, once a theory is organized, the theory has a beautiful aspect, and that is it can predict things that we didn't know before. And this is one of the beautiful aspects of science you don't see anywhere else. You don't see probably in arts, you don't see in religion, you don't see, it's pretty much intrinsic to science, and that is once you have a theory well built, this theory can predict situations, can predict facts that you didn't know before. So science is one of the few human enterprise that can bring about knowledge that was not known before, was not observed before. And then what the scientific community does is to request funds and money, ultimately you and me, we pay for this research, and money is used to build up technology that can then measure what the theory is predicting. And if the measurements confirm the theory, then the theory is robust. But if the measurements do not confirm the theory must be either reformulated or put it aside. And that goes to the initial point that I was trying to make. Nature has the last word in everything we do in science. The book of nature is the book we should always go back to find answers to our inquiry. And more than anything else, science is not dead. Science is not complete. It's an incomplete task. Because once we establish ideas in which we explain how nature behaves, history has shown this explanation, these ideas, this theory is not absolute. It's not an absolute truth. Because time will tell and will show the theory is incomplete because we find some new unknowns, some mysteries. We find some dark spots where our knowledge hasn't touched before. And that's the beauty of science, of being some constant process, some constantly evolving process of finding out what is out there. So homework, if you find questions you do not find possible answers in the book and you get in trouble, don't hesitate to email me. And we can set up a chat room, or I can go over the solutions and post it on a video. We can do things. Any question regarding homework? Okay, so let's go to discussion. So discussion can, or you will last for an entire week. And the first discussion is based on astronomy and astrology. Again, here we are emphasizing what is science and what is not. And far from me to place science as on the top of everything. The different types of I would say the different types of enterprise that human beings have developed as a tool to better understand the workings of nature. All the different tools are important in my humble point of view. I mean, science is one of them, myth is one of them, religion is one of them, arts is one of them. I mean, they are different. Um, a long time ago, I was one of, in my youth, I would say, I would be defending the idea that somehow um, science would be integrated with mythology and with religion in some kind of a unified thought that everything could be understood from that standpoint. Um, I think it's a beautiful idea, but in my opinion, I think it's not valid in the sense that they are different. And when I say they, is religion and science and mythology. They are different ways of approaching reality. And science has a very specific um, way of doing things that are different from the religious standpoint. Is there any creativity in science? Absolutely. Is there any art in the way science or scientific work? Absolutely, it does. Does intuition play a major role in the scientific discovery? Absolutely. Um, does technology play? Yes. So all of these different parts of religions, myth, arts are used by human beings, because we are human beings doing science, in creating science. But when communication of science is done, we communicate in a certain way, in a certain language that is universal. So when you communicate science here in the United States, although we speak in English, some other culture, some other group in other country, like in China, using Chinese characters and language, they will communicate and understand the same thing in their own language. But they will agree, they know what you're talking about. And this type of communication, universal communication, I would say, does not exist in religion. And I give an example. In a religious group, for instance, a group can say, oh, because God, and when that group mentions the word God, it has some specific characteristics to what that group is labeling God, which is not the same interpretation that a different group in different religion would make and would bring on the table when talk about God. And although they are talking about maybe the same thing, their interpretation and their uh, uh, understanding of what God is might be different. And sometimes they might fight with the same idea. But here in the United States, when you talk about DNA, there is no discussion of what DNA is here in the United States or in Brazil, my country, or in Russia or whatever. DNA is DNA. Quasar is a quasar, galaxy is a galaxy, and the entire community working with that, no matter where you are, which country you are, which religion you have, which ethnicity you have, they all understand the same thing. So you could say that science carries a powerful universal language that is used as a tool to find new things, to discover new things. So the point of this discussion is to find out what the group, because this is going to be done within the group, what the group think about astrology and astronomy. Astronomy is a science. We are studying astronomy as a science-based tool, but the question is, astrology is a science or not? Now, why do I put astrology here? Well, astrology in general is not considered a religion, so I would not be offending anyone if I bring that to the discussion. And also, I would like to have some sincere opinion based on facts if you, the student, think astrology can be considered a scientific enterprise or a religious enterprise or a myth or a pseudoscience or what. But as you say and express your opinion, you must pull up some facts. For instance, if you think astrology is a scientific enterprise and tool, what evidence you have? What is your evidence? But if you think it's a religious point of view, why do you think it is? Some students, because I like to debate this subject, some students claim that astrology is not a religion because it doesn't have a liturgy, it doesn't have a temple, it doesn't have features that usually religion have. It doesn't have a unique God, right? And some other students see astrology as a religion. Some other students see it as a pseudoscience. Anyway, so I would like to have your opinion, but I would like you to be involved in that. So how are you going to bring, first of all, your point, how you are going to initiate your discussion? Pretty much that's how you do. You read this thing here, and then, for instance, I'll give my example. My birthday is July 31st. So I go here in July 31st, and I see that, where is it? Here. July 31st, place the sun against the constellation Cancer, which means in July 31st, if I go to a night sky, this is a fake sky, and I will punch July, and 31st. There you go, July 31st. So let's go to the morning hour. That's the sun. Since this is a software, I will get rid of daylight, right? And I will also bring the constellations, the boundaries. There you go. And I will bring their names. And I will bring their names. Wait a second. There you go. So in July 31st, if you look at the real sky, if you could, during daytime, because, you know, you can't see stars during daytime, but if you get rid of daylight, the sun would be in Cancer. But if somebody comes to me and say, hey, when you're born, and say July 31st, oh, because you're a Leo, and then start speeding all kind of characteristics Leo, a person born under Leo would have. And then I say, hey, but in July 31st, the sun was not in Leo. Let me see some of you here. Let me see who is there. Hamza, can you speak to me? Which day, what is the day of your birth? You don't need to give the year, but just the day. Can you hear me?
January 24th.
January 24th. What's your astrological sign? If you know.
I'm not sure.
Oh, you have to know. Well, let's try. Does anybody here knows the your astrological sign? Any of you who could bring a microphone?
Yes.
Okay, who is this?
This is John Paul.
Hey, John Paul. Do you know what is your astrological sign?
Taurus, the bull.
The bull. You are Taurus. Oh my Lord! I don't want to fight you. You like to put your hand and finalize a task, and you are hard-headed. Okay, but when were you born?
May 17th.
May 17th. So May 17th, the sun was well in Taurus. that is not wrong at all. So if you are Taurus, you are Taurus. So you would give a different perspective to most of us. Say it again, John Paul.
It looks like it's on the last decan or last 10-day period within a sign.
That's interesting. You are a rare case. Does anybody else know the astrological sign? Nope. Sarah, are you there?
Yeah, I'm here. Can you hear me?
Yes, I can.
So I'm a Pisces, March 5th.
March 5th. March 5th. Where's the sun? The sun is in Aquarius. And Pisces is the next one. You are almost in an interface, but the sun was in Aquarius. So when you take a range of students and you find out, okay, so let's go to the assignment. So you said March. Let me see. You said March 5th. March 5th. So March 5th, you go right here. See, February 16 to March 11, it should be Aquarius. So then, Sarah, you would say, well, the day I was born, the sun was in Aquarius. But some astrologer friend, or I went to, you can go to this place here, Cafe Astrology, and you can check your astrological sign from there, and then you would be Pisces or so. But my astrological sign is not the same. In the case of John Paul, it is the same, so that is interesting. And then I would like you guys to discuss this difference. And that goes to point number 2. And then the point number 3 is just the discussion itself. And then I would like us to have a robust discussion on what you think astrology is. Is it science? Is it religion? What the heck it is? And then we go from there. There are some things I prefer not to go there. for some of us, astrology is something to be revered. And I had students in the past that really, because of their parents and their culture, astrology is very important. And so we should keep our discussion to a level that is not offensive to any culture, because that's not the point. The point is this a religion or a science or what? Like um, uh, Buddhism. We could discuss if Buddhism, not here in this class, of course, but if you were taking a course on religions, you could discuss if you think Buddhism is a religion or not, or is a philosophical quest or not. So here we are discussing if astrology is or is not scientific, in the sense that we consider science as it is. And would be interesting if you had the time, if you could go to the history of astrology and do a little research and find out when and why astrology started and began. It's going to take you either to ancient Mesopotamia or ancient India or ancient China, with variants in between these different cultures, but all at about the same time, between 1000 and 2000 BC. That's where uh, this tool start to be developed. And I could talk a little bit more tomorrow. But today I just want to give you some introduction to what we are doing in the course. Okay. Any question on this discussion? And the last one is that I would like to talk about today is these conversations on what prograde and retrograde motions are. Let me go back to the Starry Night software and show you something here. See the sun over there? I will bring a line called ecliptic. Ecliptic is this green line represents a line where the sun always is at any time of the year. So let me show you one thing. See, this time of the day is March 5th. That's Sarah's birthday. And it's 8:57 a.m., right? So keep a look at this clock. And the time now is ticking. Oops. The time is ticking. If I do like this, it's clicking in real time. So if you had the ability of looking at the sky like this, right? You don't look ever straight to the sun, but if you could kind of visualize the boundaries of constellations in the sky, that's what you would see. And again, I will get rid of daylight just to make a point that I want to make. And let me bring also the name of planets that happen to be in the sky on March 5th when Sarah was born. So we have this Neptune close to the sun. Oh, this is not true. Of course, Sarah was not born in 2018. I don't know which year you were born. The sun was there, but not the planets. The planets might be in different locations. But today, that's where the planets are. Neptune is close to the sun. Venus and Mercury are in Pisces. And Uranus is in Pisces, so on and so on and so on. Now, and the time is advancing 1 second at the time in this simulation. But look what I'm going to do. I'm going to advance the time. Let me move this away. I will advance the time several minutes a second. And see what's happening now? We are observing some interesting aspect of the motions that Earth is subject to. And this type of motion you are seeing there, we are going to discuss this a little bit more in depth in chapter 2. It's called the daily or diurnal motion, and it's caused by Earth rotation on its axis of rotation. So Earth spins on its axis of rotation from the western sky to the eastern sky, and as a result of this, we see the stars in the sky, if we could, moving slowly from the eastern sky to the western sky, and we call that daily or diurnal motion. So in other words, see this letter E indicative of our due east part of horizon. So imagine that Earth, not the sky, but Earth itself is the one going down. See? It's kind of rotating or spinning downward towards that eastern sky, and as a result, we see the sky kind of lifting as it could. Now, if you look in the western sky, and that's what I'm doing here, the sun is slowly setting the western sky. Look at that, W for west. And the sun is gone. And Mercury is going to be gone too. That's Taurus, the Bull's Face, Orion, the Hunter. All of them is going to be setting the western sky a few hours from now. And pretty much we are in March 5th, 6:50 p.m. Okay. Now let's go back to the eastern sky, but in the next day. March 5th, and the next day. Okay. So if we happen to look in the eastern sky, again, the sun is rising, Mercury is rising, Venus is rising. But I'm going to do something different. What I'm going to do now is stop the sky. And I'm going to talk about a different type of motion. So the motion we are seeing in the simulation is Earth rotation, or Earth spin in its axis of rotation. And as a result of this, we see the sky slowly moving about 15 degrees an hour from east to west, crossing the highest altitude due south. But I'm going to do something different. Imagine if you could stare at the same region of the sky all the time. So let me do this with maybe this region here. Let's see a region in the sky. Sagittarius. Let's keep looking at Capricornus all the time. Okay? See Capricornus, this region? We're going to be staring at it all the time. Imagine Earth does not exist anymore, but we are floating the sky, floating space, in fact, with a spacesuit, staring at that region in the sky, staring at Capricorn, and then you look down on Earth, Earth would be spinning. So, but we are not spinning with Earth. We are staring at Capricorn all the time. And we can accomplish this using this software if we can move one sidereal day at a time. Look what I'm doing now. The days are changed. See, March 9. Look now at the day. It's going to be March 10, right here, March 10, and then March 11. So if we go one day at a time, staring at the same sky region, we observe that the sun, the moon, and most of the planets have a tendency to go eastward every day. In other words, this eastward motion in respect to the stars in the background, not in respect to the horizon, our horizon, but in respect to the background stars, is one that in general they go west to east. Why is that? That's the point of this one-on-one discussion that I would like you to see it. And if you do this quickly, look at this. You notice that Mars is retrograding, is going backwards, and then Mars start prograding again. See Saturn will start retrograding right here. It's still prograding, and now stopped and retrograde. See that? Jupiter is retrograding. So retrogradation is when a planet moves from east to west in respect to the background stars, and the sun and the moon always prograde, as you can see in this simulation. Okay? So I would like you to give some opinion on this type of motion, which is the second major motion. In fact, very important in history because of this prograde and retrograde motion. Astronomers were able to develop and to move from an Earth-centered system to a solar-centered system, from Ptolemy to Copernicus. Okay. And that is our second major discussion. Both of them are closed on Monday next week. But as I mentioned in the face-to-face discussion today, I prefer that you post anything, something, as soon as possible, because I will give you a grade that is not a grade you would like to have, so that I will give you a chance to post more stuff and then talk more with me about it, and I will help you through. Okay? And pretty much that's it. Pretty much that's it, which is a lot, I think. All right? Would you guys have any question that you want to ask? If not, I will stop taping now, and let me just make sure that you all email me your understanding of orientation, or you did something in the course, so that I can make sure you are in the course for good. In fact, I could take the chance and give you your participation. Oh, you already participated in the course. You endured this chat room, which was very cool. Okay, let me go here to this part. Complete orientation is right here. And I go to Speed Creator right there. So let me start with Ashley Perez. Ashley Perez. You're there. And then you are good. Thank you. Diana Gonzalez. Where are you? Oh, I already gave you grade. Hamza Raza. You were good. And then John Paul. I think John Paul. Yeah, I already gave you points. Raymond Chin, I think I already gave points to Raymond Chin too. Yeah, I did. Sarah Castillo, I already gave, you were there. Sophia Mendoza. My daughter's name is Sophia with a PH. Sophia Mendoza. I don't have you there. How come I don't have you there? Sophia Mendoza. What is Sophia? Oh, it's right there. Sophia Mendoza. I don't have Sophia Mendoza. How is that possible? Am I reading? Sophia, are you there?
Yeah, can you hear me?
Yeah, I can. Wait a second.
I got your email because I was on the wait list, but on my Canvas, like, it doesn't show that I'm enrolled.
I know, but how come you got, I don't understand how you got into the chat room.
Because I got your email. You sent me an email saying that I got in.
Oh, I sent you an email.
Email, yes.
Do you have a do you have an ad code?
No, I think that's what I need because I was on the wait list.
Oh, it was so you need an ad code. Is that what you're saying?
Yes.
Okay, hang on there. Don't go yet. Ashley Perez, I already took care of you, right? Diana, Donna Plata. Where are you? You're there. I think you are all good. You are all good. Not Sophia. Sophia, stay there. Don't go yet. But all of you, do you have any extra, any other question you want to ask? Nope. All right. So I see you all tomorrow. Thank you for coming. And Sophia, did you email me already?
Yeah. Yes, I did.
Can you do me a favor?
Yeah.
Can you email me now? Because I have a tons of email.
Yeah. No.
And then I send you a net code.
Okay.
All right. Okay. All right. And as soon as you get enrolled, please start working because yeah, but I think you'll be fine. But try to work as soon as you can.
Okay. Do I need to do the orientation again?
No. You already know what to do, right?
Yeah.
Basically, we have 3 midterms, and the midterms you can go to Evergreen. I will be there proctoring the exams. But if you have a computer with a camera, you can do at home as long as you have Google Chrome in your computer as a browser, and then you can you have to show your ID. You have to make sure no one is in the room. You cannot go Google or go into Wikipedia. You can have 1 page of notes, and you have to show that to the camera.
Okay.
All right.
Yeah.
Cool.
I'll email you right now.
Yeah, email me right now, please.
Okay. Thank you.
All right. Good night to all of you.
Good night.
Night.